Now that you have an introductory understanding of the V-Block system's compute technology, let's switch gears and talk about the V-Block system's networking. Recall that V-Block systems are composed of a compute, network, storage, virtualization, and management technologies. In the previous section of this training, you learned about the V-Block system compute. The focus of this section is now on the V-Block system networking. The objectives for this section are listed here. Upon completion of this training, you'll be able to explain the function of the network technology within the V-Block system, distinguish between the purpose and technologies of the V-Block system's local area network, or LAN, and storage area network, or SAN. List and explain the purpose of each of the components of the V-Block system's network technology, and describe the connectivity of the V-Block system's network components. Let's get started. But first, a little trivia. The beginnings of today's Internet began as early as the 1950s as a U.S. government network used for military purposes. Homes were not networked, and there was no web-based commercial activity back then. Can you guess when the Internet was first legally available for commercial traffic? Today it's hard to imagine living life without the Internet, but it hasn't been around that long. The correct answer is 1995, which is when the restrictions on commercial traffic on the Internet were eliminated. Today, the Internet dominates our lives as a place to buy products and services, pay our bills, find relationships, seek advice, and stay connected with friends and loved ones. It's hard to believe that it hasn't even been around for 20 years. In this section, you'll learn about the function of the V-Block system's network technology.
The network is a critical part of the V-Block system. It provides connectivity between components, the communication of data and information between components. Click on and review the content of each box to learn more about these basic network concepts. The network technology provides connectivity inside and outside of the V-Block system. Inside, it provides connectivity and communication between the V-Block system components, including compute and storage devices. Inside each V-Block system is a local area network, or LAN. Today, LAN networks are commonly found in businesses, schools, and homes to carry general network and internet traffic. V-Block systems also have storage area networks, or SANs. These are different in that they are dedicated specifically to carry storage-related network traffic. Outside of the V-Block system, networking provides connectivity between the V-Block system and the site network, which handles other organizational network and communication needs. In addition to providing connectivity and moving network traffic, networks simplify data protection and migration tasks. The ability to move data over the network for these purposes creates significant data center management efficiencies. Each device on a network must speak the language the network understands. Standards setting organizations define network standards or protocols, which are divided into sections, sometimes referred to as network layers. Subsections define physical attributes like performance requirements of cabling or network switches. Other layers define processes by which the data is packaged and transported across a network. Sometimes protocols defined by multiple standards-setting organizations are combined to achieve specific network capabilities. As mentioned previously, the network types found in V-Block systems are SANs and LANs. SANs use fiber channel network standards, and on the physical network layer they utilize the Fiber Channel Protocol, or FCP. V-Block system LANs are Ethernet networks, which utilize the Internet Protocol, IP, on the physical network layer. There are protocols used throughout every V-Block system, but an important one to know about is the Small Computer System Interface, or SCSI protocol. Here's why it's important. All V-Block systems use block-level storage, which you'll learn more about later in detail. Block-level storage is one way that data is stored on V-Block systems, and it requires the SCSI protocol as one of its network layer standards. Recall that VBlock system servers have no storage. Their operating systems are located on VBlock system storage drives. VBlock system servers access their operating system over the SAN using the SCSI protocol, which is necessary to retrieve files from block-level storage. When the servers are turned on, they boot their operating system from files accessed via block-level storage on VBlock system storage drives. More details about Fibre Channel and Ethernet standards are available by clicking on the link at the bottom of this screen. VBlock system SANs utilize the Fibre Channel Network Standard. As you know by now, a SAN is dedicated to storage-related network communications between host computers and storage devices. SANs allow multiple servers of different types and platforms to access the same storage drives. It utilizes a special network switch called a SAN switch, which also supports the Fibre Channel Standard. Because a SAN is dedicated to communications between hosts and storage arrays, it can more efficiently deal with storage network traffic than a network that must also accommodate other non-storage related traffic. VBlock system servers access their operating system over the SAN using the SCSI protocol, which is necessary to retrieve files from block-level storage. The LAN uses the Ethernet network standard and the IP protocol. Think of it as a general-purpose network used by many organizations to handle a variety of network needs, like sending emails, collaborating with project teams, and printing a file to a network printer. It provides networking for basic communications between computers, printers, network switches, shared storage drives, and other network devices. Data in a file-level storage configuration is accessed using the other network protocols that enable multiple applications to share the same data in files saved to storage drives. The Common Internet File System, or CIFS, is the standard used in Windows environments, and the Network File System, or NFS, is the standard in Linux environments. Later in the storage section, you will learn more about file-level storage. Block-level storage can also be accessed over the LAN using the Internet Small Computer System Interface, or iSCSI, which is a modified version of the SCSI standard that is used in Fibre Channel networks. You will learn later that this protocol is used to provide access to block-level storage in a VBlock system platform that does not have a SAN.
You now know a little bit more about LAN and SAN networks, so we'll turn our attention to a conversation about the specific network components found in VBlock systems.
VBlock system networks utilize a combination of four components: a Cisco LAN switch, Cisco SAN switch, Cisco Unified Network switch, and the Cisco Nexus 1000E virtual switch. Let's talk about each of these one at a time. VBlock systems have LAN switches that are responsible for managing Ethernet network communications inside the VBlock system, as well as outside to company networks. Switches are network devices that receive messages from other devices on the network, and then deliver them to the device for which it is intended. In a VBlock system, the LAN switch provides Ethernet connectivity between compute and storage, as well as to the site network. Each switch comes with a number of physical ports, and more can be added using port expansion modules to increase the network capacity to move traffic. It is important to understand that not all of the physical ports that come with a switch or expansion module are licensed. For example, a switch will come with multiple ports, but licenses to use only some of them. Licenses can be purchased to activate the unlicensed ports at any time. All of the ports on a switch or expansion module can only be used if licenses for each port has been purchased. As you learned earlier, a storage area network is dedicated to the communications between computer hosts and a storage array. Because it does not share network capacity with other types of network traffic, storage-related communications can happen more efficiently on a SAN. A SAN switch directs the flow of data between hosts and storage arrays. SAN and SAN switches work using the fiber channel network protocol. As mentioned earlier, in a VBlock system, the SAN and SAN switches support the booting of compute servers over the network. When a VBlock system server is turned on, it communicates with the storage drives over the SAN to retrieve and boot its operating system. Each VBlock system contains 2 SAN switches. Instead of separate IP and SAN switches, VBlock systems can be built with a Cisco unified switch. A unified switch eliminates the need for separate LAN switches and SAN switches. A unified switch can perform the switching tasks associated with both Ethernet and fiber channel networks. There are a couple of factors that can influence the decision to use a unified switch. First, the maximum number of network ports using unified switches may not be sufficient for a customer's connectivity needs. Generally speaking, a network with separate LAN and SAN switches will have a greater number of network ports for traffic to flow through. Think of the ports on a network switch as driving lanes on a highway. The more lanes you have, the more cars that can travel the road without slowing down. The number of network ports affects the capacity of the network to carry traffic. Among other factors, the more switches and switch ports in a network, the more volume the network can handle. Unified switches usually have fewer ports and therefore cannot support as much network traffic. The combination of LAN and SAN switches offer a greater maximum number of ports than the configuration using unified switches. A second factor that customers consider when deciding to use a unified switch or not is port licensing costs. These costs can vary depending on the switch model used, and that can affect the total cost of the VBlock system. The Cisco Nexus 1000V series switch is software, not hardware, like a LAN, SAN, or unified switch. It is designed for virtualized environments. We will learn more about virtualization, virtual machines, and virtual networks soon. But for now, what you need to know is that virtualization is a means of using the resources of a system, like CPU, memory, and storage, and assigning it to virtual machines. A virtual machine is not a physical computer, but it can perform like a real computer running an operating system and applications. In a VBlock system, many virtual machines can be created as servers running specific applications. This can be a difficult concept to get your arms around right now, but you'll learn much more about this later. For now, understand that the Cisco Nexus 1000V virtual switch software plays the same role in a virtual network that physical network switches do in a physical network. Specifically, a virtual switch controls communication between virtual machines on a virtual network and between a virtual network and the physical network. Nexus 1000V switches are standard components in all VBlock system configurations.
The last topic for this section addresses network connectivity Here you will learn how the components of the network provide connectivity both inside and outside a V-block system.
You've already learned about the connectivity related to the V-block system compute components. We'll build on that here. Our focus now is on the connectivity of the network components to the rest of the V-block systems. Remember that the network components provide connectivity inside and outside of the V-block system. Inside, it connects to the internal V-block system components, including compute and storage technologies. Outside, it provides connectivity from the V-block system to a customer's site network. V-block system models can come with 2 Cisco LAN switches. In systems with blade servers, each LAN switch is connected to both fabric interconnects. This provides redundancy so that if one switch breaks down, the other can manage the connectivity needs from all of the compute servers. These switches are responsible for providing Ethernet connectivity so that the site network can access compute components. The compute fabric interconnects are connected directly to the LAN switches, which then connect directly to the site network. The LAN switch also provides connectivity between the site network and storage, so that file-level storage can be accessed from the users and computers outside of the V-block system. Later, in the next section, you will learn specifically about how connectivity is made to storage components. There can also be 2 SAN switches in V-block system models. Remember, the V-block system SAN utilizes the fiber channel standard in the SCSI protocol to provide block-level storage access. As you know, SAN switches manage data traffic between the compute servers and the storage drives. The SAN switch connects to the fabric interconnects on the compute side, and then directly to V-block system storage. Notice that unlike the LAN switches, each SAN switch connects to a single fabric interconnect. Redundancy is handled differently on the SAN side, and you'll learn more about this later. In a unified network configuration, there is no need for LAN switches, and there are no SAN switches either. These are replaced by 2 unified network switches. The unified switches will manage both LAN Ethernet connectivity and SAN fiber channel network connectivity. You've learned earlier that not all V-block systems have UCS blade components. These systems contain no blade servers, blade chassis, or fabric interconnects. Instead, they are engineered with rack-mount servers. In these V-block system models, the rack-mount servers are connected directly to the network switches. Notice that each server is connected directly to both network switches for redundancy.
This is a learning check that provides an opportunity for you to assess your progress. Each question provides feedback to help you remember the content, and a score is provided at the end so you can assess how you are doing. This is not a test and is not part of the certification assessment. Learning check scores are not retained in your records. However, completing these learning checks is great preparation for the certification assessment that comes later. You may take this learning check as many times as you want. Click Next to get started.
You're making lots of progress. Congratulations! You've completed the Introduction to VBlock System Network section of this training. Here you learned about the purpose of the VBlock System network technology, the types of networks in a VBlock system, the components of the VBlock system network, and the network connectivity inside and outside of the VBlock. Next you will learn about the basics of VBlock system storage technology.